Okay, so guys, in this video we are going to find the derivative of logarithmic functions given to us, and the thing which is very important in all of these questions is the derivative of log of x. Now the derivative of log of x is actually equal to 1 divided by x. Okay, so for our first question we have y is equal to x square log of root of x. Now it is actually the natural log of root of x, but the equation actually fits both of the terms, natural log or simply log. Okay, so let's just rewrite this function y is equal to x square log of root of x. Now actually there is a property of log. If log is having x and power m, then the power will be separated and log x will be left as it is. Okay, so over here if we see, we have x square log of x power 1 by 2. Now the square root is actually equal to power 1 by 2. Okay, so this property will be applied. X is the function and m is 1 by 2 for our situation. So we can write x square 1 divided by 2. Okay, so m is at the beginning, so we have our m is actually 1 by 2, so it would be at the beginning, then natural log of x. Okay, and now we can go ahead and apply the differentials on both sides of the equation, but before that I'm going to separate this constant 1 divided by 2 and these terms will be as it is. Okay, so we have y right over here, and then we can apply the differentials on both sides of the equation. D by dx 1 divided by 2 x square log of x. Okay, so this 1 divided by 2 is actually a constant, so the derivative won't have any effect on it, so it will be separated. And then we have derivative of x square log of x. Now these two terms are being multiplied, right? And when we have two functions, now x square is in itself a function and log of x is a function. So basically we have two functions, right? And when two functions are being multiplied, we can use the product theorem for finding the differentials. So the product theorem actually says the first function as it is derivative of the second function plus the second function as it is derivative of the second function. So the same rule will be applied over here. Okay, so let's just apply this rule. Okay, so for our situation, x square is actually fx, that is the first function, and log of x is the second function, gx. Okay, so n1 divided by 2 will be as it is throughout this question. So we have, let's just separate this 1 divided by 2 with a bracket, so it won't mess up with the terms present inside the operation. So the first function as it is, derivative of the second function, plus the second function as it is, derivative of the first function. Okay, and 1 divided by 2 x square, the derivative of log of x, which is actually 1 divided by x, plus the log of x, derivative of x square. Now it is having a power, so the power will be separated, then the function and the power minus 1, so 2 minus 1 is actually 1. Over here we have 1 divided by 2, so the power will be cancelled by x right over here, so we have x plus log of x 2x. Okay, this 2x is actually present under the bracket right over here, so we have 1 divided by 2. Let's just multiply this 1 divided by 2 with every term present inside the bracket. So 1 divided by 2 multiply x gives us 1 divided by 2x plus 1 divided by 2 multiplied by log of x multiplied by 2x. Okay, and then we can cancel these two, so we are left with x divided by 2 plus, okay, so this is the x and this is log of x log of x. These are two separate terms, so we can separate them by a bracket. So this is the final derivative of y. Now the second question, we have y is equal to x root of log of x, or actually natural log of x, and we have to find its derivative. So we can simply apply the differential on both sides of the equation. Dy by dx is equal to d by dx x root of log of x. Now again we have x, which is basically an algebraic function. Okay, we can categorize it as an algebraic function. So this would be my first function fx, and natural log of x is actually a logarithmic function, so it would be categorized as a logarithmic function, so it would be my second function gx. So we can simply use the product theorem, which I explained in the first part of the video. So we have the first function as it is derivative of the second function, so we can actually write the square as power 1 by 2 plus the second function as it is derivative of the first function, that is x. So we have x, now the power will be separated, the function power minus 1. Now 1 divided by 2 minus 1 is actually negative 1 by 2. And then the derivative of the function. What is the function? The function is anything which is present under the power. Now what is the thing which is present under the power? It is log of x. So we have to multiply it by the derivative of log of x plus log of x 1 divided by 2, so it would be as it is, and then we have, this would be cancelled, so we are left with 1. So x 1 divided by 2, so it is in the negative form. If I reciprocate it, it will become positive, and it would be much more convenient to deal with it. Then we have derivative of log of x, which is actually equal to 1 divided by x plus log of x 1 divided by 2. Now this x is cancelled by this x right over here, and we are left with 1 divided by 2 log of x 1 divided by 2 plus log of x 1 divided by 2. Okay, and after that we can simply see that over here by default we have a denominator 1, so we can take the LCM 2 log of x 1 divided by 2. So over here these two terms are matching, so we are left with 1 plus, so we have the LCM right over here, so we have 2 log of x power 1 by 2. So this is actually the rough work, I'm sorry about that. And over here we have 1 in the denominator, so 1 will be divided, and we are left with 2 log of x 1 divided by 2. Now this term 2 log of x 1 divided by 2 will be multiplied by this numerator right over here. Okay, so this is actually the basic rule of LCM. When we multiply it, it will become 2 log of x power 1 by 2 multiplied by, actually it is getting a bit messier, so let me just write it over here, 1 plus 2 log of x 1 divided by 2 multiplied by log of x 1 divided by 2 divided by 2 log of x 1 divided by 2. Okay, so I hope that makes sense. Now we can see, so over here you can see that these two functions are being multiplied, so we have, when the bases are same, the powers are added, so we are left with log of x, the powers will be added, so 1 divided by 2 plus 1 divided by 2 is actually 1 divided by 2 log of x 1 divided by 2. Okay, so this is the final derivative of y given to us. Then in the next question we have to find the derivative of y is equal to x divided by log of x. And for this question we are going to use the quotient theorem. So the quotient theorem says that if you have two functions which are being divided, i.e. fx divided by gx, we can simply derive them as gx, the second function as it is, derivative of the first function, minus the first function as it is, derivative of the second function, divided by the square of the second function. Okay, so we have x, which is an algebraic function, so it would be my fx, and then we have log of x, which is actually a logarithmic function, and it would be gx, i.e. the second function. Then we can simply use this property right over here. So we have the second function as it is. Oh, first of all, we have to apply the differentials on both sides of the equation. So dy by dx is equal to d by dx, x divided by log of x. Okay, so the second function as it is, derivative of the first function, i.e. x, minus the first function as it is, derivative of the second function, i.e. natural log of x, divided by the square of the second function. Okay, so over here we can further go on and cancel these terms. So we are left with natural log of x minus x, and the derivative of log of x is actually 1 divided by x, so 1 divided by x divided by, and over here these terms are cancelled, so we are left with 1. So we have natural log of x minus 1 whole square, and this is the final derivative of this function. Okay, so guys, now in the next question we have y is equal to x squared natural log of 1 divided by x. Now first of all, this 1 divided by x is bothering me, so I can write it as natural log of x negative 1. Okay, and before going ahead, I wanted to give a disclaimer that if you want to try these questions on your own, go ahead, free feel to try them, because these are super simple. The basic concept were that of the derivative of the natural log of x and those product theorem and quotient theorem. So these questions are actually based on all of these theorems, and I'm just demonstrating how you can use those theorems in order to solve some question related to the derivative of log of x. Okay, so these questions are pretty simple and you can try them on your own and you will be super successful. Okay, now let's continue with the question. Okay, I told you in the previous question that we have log of x m, and we can write it as m log of x. Okay, so it is basically a property of log. Over here we have the same thing. We have log, natural log, x, and then m is negative 1. So we can separate it x squared negative 1 natural log. Okay, and now we can go ahead and find the derivative. So y, we can simply put the derivatives on both sides of the equation. The negative 1 is a constant, it would be separated. The derivative of x squared and natural log of x. Okay, so we have negative 1. Now this is my fx and this is my gx, and these two are being multiplied, so we can use the product theorem. So let me just separate it by a bracket. So we have the first function as it is, derivative of the second function plus the second function as it is, derivative of the first function, i.e. x squared, minus 1 x squared, derivative of log of x is 1 divided by x, plus log of x, derivative of x squared is 2x. Okay, then we have negative 1, so this power is cancelled by this right over here, x plus natural log of x 2x, and we can simply multiply this negative sign with everything present inside the brackets, so we are left with negative x negative log of x 2x. Okay, so this is the final derivative of this question. Moving on towards this question is actually a pretty trickier, but the good thing is that we only have one function, log. So before continuing with this question, before applying the differentials, actually we know that log xm is actually equal to m log of x, right? And over here, if I just simplify this equation as log of x squared minus 1 divided by x squared plus 1 1 divided by 2, we can see that this term right over here will be my x and this term right over here will be my m. So this property can actually be applied to this equation right over here. So I can write m in the beginning, 1 divided by 2, then the natural log, and then the function x square minus 1 divided by x square plus 1. So this property actually holds for this question also. So now I can go ahead and apply the differentials on both sides of the equation. So 1 divided by 2, the derivative. Okay, so from here you have to pay attention. On it, you can see we have log of x square minus 1 divided by x square plus 1. We know that the derivative of log of x is 1 divided by x, right? Over here we have x square minus 1 x square plus 1 instead of having x. So what would be the derivative? It would be 1 divided by x square minus 1 divided by x square plus 1. Okay, and then the derivative of the function. Now what is the function of log? It is x square minus 1 divided by x square plus 1. Okay, so the derivative of x square minus 1 divided by x square plus 1, this is actually the function of log, and this entire thing is actually a function in itself. So this is actually the rule of differentiation, that you have to find the derivative of the function, and then you have to find the derivative of the function present inside that function, and then you have to continue this process until you are left with 1 or 0. Over here we can simply write 1 divided by 2, and this term is actually present in the denominator of the denominator. Let me explain what I'm trying to say. So if you see, we have something like x divided by a divided by m. Now if we have m, it is actually the denominator of the denominator, so it will be written as m multiply x divided by a, i.e. it becomes the numerator. In our situation, this thing right over here represents m. It is actually the denominator of the denominator, so it can be written as 1 multiply x square plus 1 divided by x square minus 1. Okay, so it becomes the numerator. Right, so I can write it as x square plus 1 divided by x square minus 1 multiplied by. Okay, so we can use the simplest form of the quotient theorem for solving for the derivative of this thing right over here. So this would be my fx, the first function. This would be my gx, the second function. Let me just find the differential of this part separately on another page so that it would be much more clear. So we have these two functions, right? And this is my fx and this is my gx. So the second function as it is, x square plus 1 derivative of the first function, i.e. x square minus 1, minus the first function as it is, derivative of the second function, i.e. x square plus 1 divided by the square of the second function. Okay, so from here x square plus 1, the derivative of x square is actually 2x, and the derivative of negative 1 is actually 0 because it is a constant. Minus x square minus 1, the derivative of x square is again 2x, and the derivative of positive 1 is 0 because it is a constant. Now let's just multiply this 2x inside these terms. So we have 2x cubed plus 2x multiply 1 is 2x minus 2x cubed minus positive 2x divided by, so these terms are cancelled and we are left with 4x divided by x square plus 1 whole square. Okay, so the derivative of x square minus 1 divided by x square plus 1 was 4x divided by x square plus 1 whole square. Okay, and this square will be cancelled by this power right over here, and we are left with 1 divided by 2, 1 upon x square minus 1 multiplied by 4x divided by x square plus 1. Okay, so actually these terms are being multiplied. Okay, so I can remove the brackets and we will be left with 1 divided by 2 multiplied by 1 divided by x square minus 1 multiplied by 4x divided by x square plus 1. Okay, and this 2 will be cancelled by this 4 right over here, so we are left with 2x, and we have 2x divided by, in the denominator we are left with x square minus 1 and x square plus 1, so we have x square minus 1 and x square plus 1. And this thing, you can leave this question right over here. This is actually the answer of this question, but I want to go a step ahead, and we can see this, these terms are actually a minus b, a plus b, so it can be written as a square minus b square, which is actually another theorem of algebra. So we have 2x divided by a square minus b square. Now over here we have a x square, a is my x square and 1 is my b, so we can write a square x square whole square minus b square, that is 1 squared. So we have 2x divided by x square minus 1. So this is the final derivative of the y. Okay, so we have y is equal to x plus root of x square plus 1. Now remember, this is actually a function of log. Okay, it is actually present inside the, you can consider it something like log of x. Okay, so this entire thing is my x. Now we know that the derivative of a log of x is actually 1 divided by x, right? So I can write this thing. First of all, let's just apply the differentials on both sides of the equation. We are left with d by dx log of x plus square root of x square plus 1. So according to the formula 1 divided by x, we can write 1 divided by, instead of writing x, we can write x plus root of x square plus 1 multiplied by the derivative of the function. Now what is the function? It is this thing right over here. So d by dx, x plus d by dx, x square plus 1 power by 2. And yeah, I made some alterations to this term. I separated the differential because these were being added, so we can separate the differential in case of subtraction and addition. And instead of writing the square root, I wrote 1 divided by 2, which is actually equal to square root. Okay, so this term will remain as it is till the end of the question. So multiplied by the derivative of it would be cancelled, and we are left with 1 plus the power as it is, the function power minus 1, x square plus 1 divided by 2 minus 1 gives us negative 1 divided by 2 multiplied by the derivative of the function. Now what is the function of the power? The function is anything which is present under the exponent. Now we have x square plus 1 present under the exponent, so the derivative of x square plus 1 divided by multiplied by 1 plus 1 divided by 2. It is in the negative form, so if we reciprocate it, it would become positive, so we are left with 1 divided by 2 in the positive form multiplied by the derivative of x squared. Oh, actually let me write it in a much bigger form because it is confusing. So the derivative of x squared is actually 2x, and the derivative of 1 is 0 because it is a constant. So this 2 is cancelled by this 2 right over here, and we are left with 1 divided by x plus square root of x squared plus 1 plus, over here we are left with x multiplied 1 gives x divided by x squared plus 1 divided by 2. And we can now multiply this term inside this bracket, so we are left with 1 multiplied this term gives us 1 divided by x plus square root of x squared plus 1 plus this term will gives us x divided by, okay, so we have x square plus 1 power 1 by 2 x plus square root of x squared plus 1. Okay, so this is the final derivative. Moving on towards a very simple question. We have log of 9 minus x squared, and we can simply apply the differential on both sides of it. Dy by dx, d by dx, log of 9 minus x squared. Okay, we know that the derivative of a log of x is 1 divided by x, right? So we can simply, this thing will be considered my x. So we have 1 divided by, instead of writing x, we have 9 minus x squared. And then the derivative of the function, what is the function? It is this thing 9 minus x squared. So we have derivative of 9 minus x squared. Okay, so 1 divided by 9 minus x squared, we have d by dx, 9 minus d by dx, x squared. Let me just separate it with the bracket. 1 divided by 9 minus x squared multiplied by the derivative of any constant is equal to 0. So we are left with 0 minus the derivative of x squared is 2x. So 1 divided by 9 minus x squared, and we have negative 2x. So the final derivative is negative 2x divided by 9 minus x squared. Okay, so we have to find the derivative of this function log of Euler x plus Euler power negative x. Okay, so we are basically combining the derivative of Euler's and the derivative of logs. Okay, so we know that the basic function right over here is log, and the Euler's are present inside the function of log, right? So the derivative of log x is 1 divided by x. Okay, so this thing right over here will be considered my x. So we can simply apply the differentials on both sides of the equation. D by dx log of Euler x plus Euler negative x. Let me separate this thing. Our x is Euler x plus Euler negative x, so we can write 1 divided by Euler x plus Euler negative x. Now the derivative of the function, now what is the function? It is Euler x plus Euler negative x. So Euler x plus derivative of Euler negative x. This term will be left untouched until the end of the question. And the derivative of Euler x. Now, the derivative of Euler x is actually Euler x, and you can access the formula sheet in the description below. Plus, now this derivative, Euler negative x, is actually a function. So when we have negative x, we are actually having negative 1x. So we have a mix of constants and numbers. Okay, so we learned in the, I think, video number 80 of this playlist, in which we said that the derivative of Euler x is actually equal to Euler x, but the derivative of Euler having a function as a power will be equal to Euler function multiplied by the derivative of that function. So we can write Euler negative x multiplied by the derivative of that function. Now what is the function? This is my fx right over here. So we have derivative of negative x. Okay, so I hope that makes sense. Euler x plus Euler negative x, Euler x plus this thing will be cancelled, but we are left with a negative sign. So this negative sign will be multiplied this positive sign. We are like negative. We have Euler negative x. Then we have simply Euler x minus Euler negative x divided by Euler x plus Euler power negative x. So this is the final derivative of this question. So we have another question which is actually related to, so it is actually related to the combination of log and Eulers, okay? But in here, in this function, there's something unique. This square root is actually present over both Euler and the log, okay? So we can simply write it as Euler 2x plus Euler negative 2x power 1 by 2, okay? So I hope that makes sense because the square root is actually equal to 1 by 2. Now let's just apply the differential on both sides of the equation, d by dx log of Euler 2x plus Euler negative 2x 1 divided by 2. Okay, so a couple of things going on over here. The function of the square root is this thing, log of Euler 2x plus Euler negative 2x. And then the function of natural log is Euler 2x, Euler negative 2x, okay? So we will use the power will be as it is, the function natural log of Euler 2x plus Euler negative 2x. So this is actually the function, power minus 1. So 1 divided by 2 minus 1 is actually negative 1 by 2, multiplied by the derivative of the function. What is the function? Log Euler 2x plus Euler negative 2x. So let me just separate it by a bracket right over here. And we have 1 divided by 2. So we can reciprocate this thing. We have Euler 2x plus Euler negative 2x powered by 2 multiplied by the derivative of log of x is actually 1 divided by x. Over here this is my x, so I can write the derivative of log of x would be derivative of 1 divided by Euler 2x. I'm messing up with the denominator. Euler 2x plus Euler negative 2x, and then again the derivative of the function of the log. What is the function of log? This thing right over here, multiplied by the derivative of Euler 2x plus Euler negative 2x. Okay, so I hope that makes sense. It is actually a bit confusing, but yeah, if you concentrate on it, it would be simpler. Okay, so 1 divided by 2, this term. Now this term right over here will remain as it is, okay? So you do not have to mess up with this term till the end of the question. Multiplied by 1 divided by Euler 2x plus Euler negative 2x. Let me just do this thing on a separate page. Okay, so let's just apply the differentials. Euler 2x plus derivative of Euler negative 2x. So the derivative of Euler 2x would be Euler 2x multiplied by the derivative of the function. What is the function? This thing right over here, 2x. Oh, I'm sorry about that. Plus this would be as it is, Euler negative 2x, and then the derivative of the function is negative 2x. So we have Euler 2x, this x will be cancelled, but we are left with 2. Plus Euler negative 2x, this x will be again cancelled, and we are left with negative 2. Now this negative sign will be multiplied by this positive sign, so we are left with negative, and this 2 right here. So we have Euler 2x minus Euler minus 2x. So we have Euler 2x minus Euler minus 2x. So we have power 1 by 2 multiplied by Euler 2x minus Euler minus 2x divided by Euler 2x plus Euler minus 2x. Oh bro, I forgot to put the 2's over here, so the 2's will be taken out as common, and we are left with Euler 2x minus Euler minus 2x. So the 2's will also be placed over here, and over here, this 2 will be cancelled by this 2 right over here, so we are no more left with 2's anymore. Okay, so this is the final derivative. Now for the final question of this video, log of root of Euler 2x plus Euler negative 2x. The function of log is actually this thing. And then the function of square root is Euler 2x plus Euler negative 2x, okay? So you have to keep that thing in mind, and let's just apply the differential on both sides of the equation. So we have d by dx log of root of Euler 2x plus Euler negative 2x. So the derivative of log of x is actually 1 divided by x. So we have, this is my x, okay? So we have 1 divided by root of Euler 2x plus Euler negative 2x multiplied by the derivative of the function. Now what is the function? This is the function. So we have derivative of Euler 2x plus Euler negative 2x power 1 by 2. Okay, so 1 divided multiplied by, the power will be separated, the function as it is, then the power minus 1 negative 1 by 2, and then the derivative of the function of the square root. So d by dx Euler 2x plus Euler negative 2x. Okay, well, we won't touch this thing because it will be left as it is until the end of the question. Multiplied by 1 divided by 2. Now this is actually in the negative form, so we can separate it. Euler 2x plus Euler negative 2x 1 divided by 2. Now just as a note, this term and this term will be left as it is until it is cancelled by something else from this term, or it will be just written as it is in the answer of this question. Okay, and let me just solve this thing on a separate page. So we have derivative of Euler 2x plus the derivative of Euler negative 2x. Now I solved this thing in the previous video actually. So we have Euler 2x, then the derivative of the function. Now what is the function? 2x is the function, plus Euler negative 2x. What is the function? Derivative of negative 2x. So x will be cancelled and we are left with Euler 2x, 2 plus Euler negative 2x minus 2. Okay, we have done this thing in the previous part, so I'm not really worried about it. So we have Euler 2x, 2 will be separated, minus Euler minus 2x. Okay, so this was actually the function. So we can put it right over here, 2 Euler 2x minus Euler minus 2x. So yeah, 2 is cancelled and we are left with 1 divided by, no, this thing is left in the numerator. So we have Euler 2x minus Euler minus 2x divided by, there's a thing. This thing is actually 1 divided by 2. Okay, so the square root is actually 1 divided by 2. So we have Euler 2x plus Euler negative 2x, 1 divided by 2 multiplied by Euler 2x plus Euler negative 2x, 1 divided by 2. So the bases are literally same. So we can add the powers. So we have Euler 2x minus Euler minus 2x. So when the bases are the same, the powers are added. 1 divided by 2 plus 1 divided by 2 gives us 1. So we are left with Euler 2x plus Euler negative 2x. And that's the final answer of this video. Okay.